as was proposed originally. So, well, I will talk in these 4 classes about, I will give an introduction to evolutionary game theory, and I will start from the very beginning, from very basic concepts, and we will increase the complexity of the concepts in the following classes. So I come from this place. This is Centro-Atómico-Bariloche and Instituto Balseiro. They are in the same place in a city that is by a lake. This is a view of the city. And these are our premises in Bariloche. This is an aerial view of the Centro-Atómico. This is a lake. This is the Nahuel Huapi Lake. And this is where I am working now. I will start by defining what is a game in words. And there are several definitions of what is a game. We can say that a game is a situation in which 2 or more players compete, or it is any situation in which individuals must make strategic decisions, and this is something important, strategic decisions, and in which the final result of this competition depends on what each of one decides. So depending on what one player and the other decide, they will have some payoff. And we will define in brief what is payoff, what payoff means. We can say also that a game is any decision-making problem. And again, decision-making, this is a keyword, where the payoff, I will tell you what is a payoff, that the person obtains depends not only on her own decisions, but also on the decisions of the other people participating in the game. So this concept and the other one are more or less the same. So what is game theory? Game theory is a formal way of analyzing the interaction between agents that behave strategically. So a formal, mathematical way of analyzing these interactions is also the mathematics of decision-making in a conflict situation. And it can be applied in economics, it can be applied in military affairs, in politics, in ecology, in ethology, sociology, a lot of fields in science. So game theory is the study of rational interactions in games. And again, the word rational is important, and we will see why it is important to understand the extent of the concept of rationality. So game theory is the study of rational interactions in games, and it's the study of the logic of interaction in the games. It's the study of how agents can do as well as possible in games. So all this is the game theory and the goal of game theory. We will see, we have 2 words. We have the word game and the word theory. Game is, what we have already seen, is something that is related to confronting players, to strategies, to decision. And theory is the idea of trying to explain how this interaction occurs and how the players can take one or the other decision, and how to predict the behavior of the players. So the goal of the game theory is to find the patterns of rational behavior. Again, I didn't define already what is rational. We will see it in the next slides. But the goal of game theory is to find the patterns of rational behavior in which the result depends on the actions of the interactive players. So what is the origin of game theory? The origin of game theory can be traced to the work or was first formalized by the work of von Neumann and Mongersten in 1945 in a book that is called The Theory of Games and Economic Behavior. And through the time, it has found, as I mentioned before, applications in economics, politics, biology, computer science. And which are the elements of a game? And this is something important because we will be referring to agents or players, strategies, and payoff throughout all the classes. So agents or players are individuals, are companies, groups, people, countries that are the players who make decisions. So the agents are those who are playing and make the decisions and can choose from a set of possible alternatives. What are these alternatives? These alternatives are the strategies. This is the second concept in game theory. Strategies are the actions the action plans, and they anticipate the decisions which regard to the future. So strategy is the set of possibilities for taking a decision. So I cannot, when I define a game, I need to define which is the universe of different strategies that I can have in order to decide what I will do at the moment when I am playing with another one. So strategies are the action plans, and one strategy corresponds to each course of action a player can choose. So we have the players, we have the strategies, and the other thing that is important to game theory is the payoff. So the payoff are the earnings that correspond to the returns that each player gets when the game ends. So I am playing with another player. I choose one strategy, the other player chooses another strategy, and depending on our choices, each of one gets a different payoff, a different earning, or I mean earning, but can be something that I lose. It's a loss, can be a loss also. Earning is the payoff, what I get from the interaction with another player. And we will see that there are different ways of representing a game. We will attach to the normal form representation of a game, where we will have something that is called the payoff matrix, where all the payoff will be included or coded in this matrix. So all the possible payoff of each strategy competing with another strategy will be coded in this payoff matrix. So we will see what is a payoff matrix and a different way of representing a game that is not the normal form and is not represented by a matrix but by a tree. But this is something we will see in brief. So what is rationality? And this is another concept that I told you before that is very important because it somehow defines how the player behaves. So in a game or in game theory, decisions are made by individuals that try to maximize their benefits and minimize their cost. So this is the idea of rationality. Each individual will try to maximize the benefit and will try to minimize the cost of these benefits. The players will make decisions about how to act. Act means adopting a given strategy by comparing these costs and benefits in different actions. So I will try to make a decision of which strategy I will choose by comparing if this strategy will give me a better payoff or a higher payoff or a lower payoff, depending also on what I can expect from the other player. And beyond the idea of this rational choice, there are two concepts, or there are two authors that have written two books. And I took from these books two statements that reflect quite well the idea of what is a rational player. Adam Smith, in 1776, he wrote, "It is not from the benevolence of the butcher, the brewer, or the baker that we expect our dinner, but from their regard to their own interest." That means that it is not that the butcher will give us our meat, but he's selling this meat. So depending on, he will have a price for this meat, and it's not that he's benevolent, he's making his own benefit in this transaction. And some years later, in 1836, John Stuart Mill, that was an economist, and in his book, Political Economy, he wrote, "A political economy does not treat the whole of a man's nature as modified by the social state, nor of the whole conduct of a man in society. It is concerned with him solely," and this is important, him solely as an individual, as a being who desires to possess wealth and who is capable of judging the comparative efficacy of means for obtaining this end. That means that the individual, a person, the only thing that is looking for is to act individually to obtain the greatest payoff. And this is the idea of what is a rational player. A rational player has no compassion, has no regard for the other one. The only thing a rational player wants to do is to get the maximum from the transaction. So there were some, this idea is what gives place to the concept of Homo Economicus. Homo economicus is a character that acts to obtain the greatest welfare for himself using all the available information on opportunities and constraints. In a way, it suggests a rational, selfish, and effort-averse individual. So this is the idea of Homo economicus. And this is what is behind the theory or game theory. The player is an Homo economicus. There was a sociologist that is called, I think he's still alive, Ralph Dahrendorf, who tried to somehow soften this concept of Homo economicus that was really very hard. And he defined the concept of Homo sociologicus, referring to an individual or to the image of a human where this individual which will be somehow affected by society and will be modeled not only by individual decisions, but also by what this individual can learn or can get from the society. So it's not that the individual is not a selfish individual, but is an individual that somehow has some constraints because of this individual living in a society. And the idea of this new individual or this new concept was called Homo sociologicus. Nevertheless, game theory always uses the concept of Homo economicus for the modeling, not the concept of Homo sociologicus. So let's go to different types of games. We will find in the literature that there are two different types or two big groups of different games. One of the games are called cooperative games, and the other one are called non-cooperative games. In the cooperative games, the players can negotiate binding contracts, so they can try to communicate each other. They can try to get or to reach consensus and try to bind the contract. And they can choose strategy together. There is a discussion, there is a consensus about what strategy to adopt because they cooperate among them. In the non-cooperative games, and these are the games we are going to talk about in the next of the classes, the players cannot negotiate a binding contract. So each one chooses his optimal or her optimal strategy independently. So I don't care about the other individual. I don't want to cooperate with the other individual. The only thing I can do is just to do what is better for me. I don't care for the other one. And this is the idea of a non-cooperative games. And this is what we are going to talk about in the next classes.
Excuse me, Marcelo, can you give an example of the cooperative? This is easier to...
Yes. Cooperative game is, for example, suppose that you live in a country that is having elections, presidential elections. And after the first, so after the first round, there are two candidates, and there are other candidates that were not included because they didn't want. So a cooperative game is just to form a coalition with one of these candidates just to try, instead of competing and to be non-cooperative players, they cooperate to form a stronger coalition. This is an example of a cooperative game, more or less, a cooperative situation. Okay.
You are considering that all the voters
Yes.
are the ones to play?
Yes, this is only an example. No. So, what is important in non-cooperative games? The player understands the point or takes the point of view or adopts the point of view of a rational player. And also, I should understand that my adversary also will play rationally. So I have to understand that I will play rationally, but my opponent will also play rationally. So both of us will play rationally. And this is what is a central point in game theory. Each player knows that the other individual will play rationally. Okay? So taking into account this thing, both players will deduce which should be their own response to the other actions. Okay? So, for example, in non-cooperative games, it is not possible to negotiate and to enforce a contract binding between players. For example, this is an example of non-cooperative games that is easier always to find. Two rival firms take each other's likely behavior into account as they independently set their prices and advertising strategy to capture more market share. So there are two firms that compete because they offer the same product, so they do not cooperate. Each of these firms just chooses its own strategy in order to get a bigger share of the market. Okay? So this is a non-cooperative situation. So independently of a game being non-cooperative or cooperative, there are some subclasses of games that I want to mention. We have, for example, zero-sum games. And the zero-sum games are games in which what one player wins is what the other player loses. So, for example, if we, for example, in the poker is a zero-sum game because there is no external income. There is nothing putting money on the game just to be distributed among the players. So what I decide how much money I will bet, and the other player also, and the one which wins takes what the other one is losing. So this is a zero-sum game. There's some other games, and we will see some examples where this situation is not what is happening. So sometimes the game is not a zero-sum game because what I lose is not what the other wins, and vice versa. Games can be simultaneous or sequential. Simultaneous means that players play simultaneously, or if they don't play simultaneously, they are unaware of what the other player is playing. So, for example, scissors, rock, and paper, it is not very funny if I am the first to make, for example, rock, and the other one say, oh, paper. This is trivial. So the idea is that both of us play at the same time. So this is a simultaneous game. A sequential game is when one player knows what the other player has already played. So for some games, it makes sense to play it sequentially, but for other games, it doesn't make any sense because it is clear what to play after I have seen the other player play. Games can be single or repeated. A single game is when I play only once, and a repeated game is when I play several times. And for evolutionary games, that's something that we will see in the next classes, the games will be repeated. So for the evolution to take place, it is important that the game will be played several times. So if I play the game only once, there is no evolution possible. There is no change of strategy possible if there is only one round of playing the game. And finally, I will mention what is complete versus incomplete information. And the concept is very clear. Players may have all of or only part of the information about the opponent. So if I know what the other opponent can do, I have a complete information. If I don't know exactly which are the strategies that are available for the opponent, I have incomplete or partial information. And again, there are some times when the situation leads to a complete information scenario, and there are some times when the situation leads to an incomplete information scenario. So I mentioned before that we have two different ways. There are more ways, but there are two principal different ways of representing a game. One is called the extensive form, where what we do is a game tree, and the other one is the normal form, where what we do is a payoff matrix. And I will, instead of reading this, I will just introduce an example, and we will see the extensive representation and the normal form representation. This is the first game I will introduce here. And this is the game with which you will be working in the hands-on. It is called the Prisoner Dilemma. It's a very simple game. And here I will just consider that there are two players playing at the same time, what you will have to do is just to consider that there are many players playing at the same time. Okay? Here, there are only 2 players. And it is one of the most famous games studied in game theory. And we will back later to it. So the idea of the game is the following. There are 2 suspects that were arrested by for a crime. And the police department wants to extract a confession. So the police offered to each of the prisoners a deal. And what is the deal? The deal is the following. The prisoners are put in separate rooms, and to each of them, the same offer is made. And the offer is the following. If you think, that means if you just tell us that the other partner or the other prisoner has committed a crime, so if you think your companion, but your companion doesn't think on you, you get 1-year sentence, and your companion gets 4-year sentence. Okay, so let's do. Think, not think, not think. So if this thinks and the other one doesn't think, so I receive 1 and the other one receive 4. If you both think on each other, you will each one get 3-year sentence. So both think, so 3, 3. If neither thinks, we will get tried for a lesser crime, and each gets only a 2-year sentence. So no think, 2 and 2. And this is 4, 1. Okay? So this is more or less the payoff matrix. We will see it in the next slide. There are 4 combinations of strategies. That is think, 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 not think, not think, think, not think, not think. So we have 4 combinations, and each combination has 2 payoff. So we have 2 payoff here, 2 payoff here, 2 payoff here, and 2 payoff here. So let's see how we can represent this game in the extensive form by means of a tree, and then we will see how to represent it by a normal form that is more or less this. This is more or less the normal form. So this is the extensive form. So we have a tree here. This is a tree. And the idea is that this is played simultaneously, but the representation is not simultaneous. But the idea is, suppose that the player 1 think, so we are here. If the player 1 don't think and remains in silence, we are here. So these are the 2 possibilities for player 1, and we have 2 possibilities for player 2. Okay? So independently that this is represented as a sequence, we have to understand that the game is played simultaneously. This is only a representation, okay? So this is a tree, and what we have is the possibility for player 1 to think or to remain silent, and the possibility for player 2 to think or remain silent in both situations. And here we have the payoff that each of the player gets according to the action of each of them. So this is what is called the extensive form, and it's only a representation. It's not that the game is changing. It's just how to represent the game in the form of a tree. The other form that is called the normal form is something that I have already displayed here, is what is called the payoff matrix. Instead of making a tree, what I do is a table, that is this one here, and from this table, what I get is a matrix. And this matrix, I don't know, I don't know where I get this for, well, okay.
Tree is equivalent to 1, 1?
Yeah? Yes.
Okay.
Oh, yes, yes, there is a problem here. But the idea is that think is 1, 1, silent think is 0, 3, think silent is 3, 0, and silent is 2, 2. So the values are different from this one. This is my mistake. But from here, we can write this matrix. And this matrix that is called the payoff matrix should be understood in the following way. This is the payoff that the player at the file gets when confronting the player at the column. So this is the payoff for this player, not for this. So this is the payoff for this one, okay? This is the payoff for this one, this is the payoff for this, and this is the payoff for this, when confronting this player or this strategy and this strategy. As this is a symmetric game, because we can see that there is a symmetry, so the only thing we need to do is just to get this matrix and understand that what we are getting here is the payoff of the strategy in the file when confronting the strategy at the column, okay? And this is all. And this is what is called the payoff matrix, and this is called the normal representation of the game. Sí, está mal. Sí, dice. Yeah, this was wrong. So, okay. So let's go to a concept that is important and is related to another important concept that is the Nash equilibrium that we will see following this idea. So what is called a dominant strategy? Suppose that we have a normal form game that is defined by a triplet, and the triplet is the individual, the number of individuals, the set of strategies, and the payoff that this strategy gets when confronting the other one. So this is what we need, the three elements that I mentioned at the beginning, the players, the strategies, and the payoff, okay? And suppose that what I do is I define S minus I as the gain, or here we have, this is the payoff. This is the strategy or the set of strategies that correspond to the strategy of the other players except Y. So this is the set of strategies to which a given individual I will be confronted to. So I will be confronted to as minus I. So this is all the possible strategies, or what I call the strategy profile, to which a given individual I will be confronted to, okay? So suppose that I take one of the strategies from the set of possible strategies for individual I, okay? So I will say that a strategy is dominant is if for any, and this is important, for any strategy different that, for example, I has adopted, the payoff of this strategy SI when confronting with the rest of the individuals is always bigger or equal to any other strategy that I can get or can choose when confronting the same set of individuals. That means that this is the best strategy that the individual I can choose from the set of all strategy available for him or for her, okay? So this is what I call a dominant strategy, meaning that this is the best strategy I can adopt, taking into account that I will be confronting some individuals that will have a given set of strategies, okay? So this is the concept of dominant strategy. So dominant strategy is a strategy SI belonging to the set of available strategy for the player I, if, as I mentioned before, this strategy has the higher payoff when confronting with the other individuals than any other strategy that can be chosen by the player I. So SI is one of the strategy, S prime I is another strategy, but always for this one, the payoff is bigger or equal to any other payoff get by any other strategy that can be chosen by the player I. So this is the concept of dominant strategy. So a dominant equilibrium is a strategy profile, that means a choice made by each of the players, where each of the players has chosen the corresponding dominant strategy. So if each player adopts the dominant strategy, this is what we call a dominant equilibrium. But the important thing here, or the important concept, is the concept of Nash equilibrium that is related to what we have seen before. We will come back to Nash equilibrium in a more formal way. Today, the idea was just to introduce the concept. We will formalize all this in the following classes. So, okay, I will finish soon. So a Nash equilibrium is reached when each player chooses a strategy that is the best option, given what the opponent are doing. It is not convenient for any of the players to deviate from the chosen strategy. That means that if each of us are playing the Nash equilibrium, there is nothing interesting in trying to change the strategy, because if I change my strategy, I will be doing worse than if I remain with the given strategy. And the same occurs for the other players. So the players are stuck in a given choice because this is the best thing they can do. If they move from this choice, the thing will be worse for them. Okay? This is the idea of a Nash equilibrium. Anyway, we will see this again in a more formal way. So a Nash equilibrium involves strategic choices that once that were made provide no incentive. There are no incentives to change their behavior. And the idea is that it's the best choice for each player given what the other players have chosen. How much time do I have? At 1, we should finish. Okay, so I will finish here, and tomorrow I will come back to this concept, but I just want to mention this. We will work, the idea of this hands-on is to work to increase gradually the complexity or the difficulty of the work you will be doing. So the first thing you will need to do is just to generalize the prisoner dilemma to a situation where instead of playing only 2 players at the same time, there are multiple players. So there are 3, 4, or n players playing at the same time. This is the first task. Then what we will do is just to play this game that you have elaborated to play this game of on a network. But for this, we need to introduce the notion of evolutionary game, because if not, you don't know what to do with a network. Because on this network, the players will need to play several times, and they will be able to change the strategy. But in order to know how they will change the strategy, you will need to understand the concept of evolution for the game. So this is something that we will be seeing in the next classes. And then the idea is to compare what happens when we are in a network and we are considering that individuals are only playing in pairs. So they are individual games. So each individual only play with another individual at a given time, or when individuals are in a given network can play in a collective form. That means one individual will play at the same time with all the individuals that are connected among them. And for that, the concept of clustering is very important, because only those individuals that are clustered will be able to play among them in a multiple player game, okay? So the idea is not to do this from the beginning, just to work gradually, starting with the idea of generalizing the prisoner dilemma to a multiple player game, and then we will go on with what is following next, okay? So I will finish now because it's time to go eating, and tomorrow I will start from where I stopped today, okay?